There we go. Perfect. Welcome everyone to this conversation with Hermione Crease. My name is Magdalena. I'm Knowledge Exchange Coordinator for CIAT Scotland East. And today we'll be looking at indoor air quality, health and wellbeing, and how monitoring can assist in developing our designs. And without further ado, I'll hand over to Hermione Crease. Over to you, Hermione.
Terrific. Thanks very much, Magdalena. Thanks to everybody who's attending. I'm very aware that I'm standing between you and your sandwiches, although probably you've got a sandwich at your desk if you're wise. I'll try and make this reasonably brisk. Let me just share a deck with you so we can get into this. Hopefully you can all see this. That come through okay, Magdalena?
Yes, that's perfect. Thank you.
Great. Okay. So, as Magdalena said, I'm Hermione. I'm the CEO of Permetrics. Who are Permetrics? We are a small business based in Cambridge. We have a specialisation in building performance measurement. So, amongst other things, we look at indoor environments and energy to understand more about the performance of homes in particular, and to help people manage retrofit projects better. And today I wanted to discuss really the uses of data and monitoring in improving the performance of buildings. Particularly, I thought it'd be interesting to look at post-occupancy evaluation for housing retrofit projects. We're going to quickly run over what monitoring involves, have a look at how it fits into retrofit projects, large and small, maybe consider what it is that we can learn from monitoring data, and we'll finish up with a few insights from the latest projects that Permetrics have been delivering. And when we talk about monitoring, I think people's minds mostly go straight to sensors like the ones that we supply. And absolutely, monitoring relies on data collected in situ, either with dedicated sensors or with devices like smart meters, smart thermostats, but actually effective monitoring tends to go a little bit further. It tends to use that data to start to drive some calculations on the performance of the fabric of the building and to drive some insights into what's happening in that building. And alongside, and that implies that there is a process for effective monitoring, and also implies that it's important to present the results of that process in context, in the context of the survey data that you might have around the fabric of the building, in context of what the homeowners, about the homeowners' preferences and behaviours, all of which is to say that actually we see monitoring as very much an additional professional surveying service. And in terms of what we deliver, our focus has been on delivering tools to the professionals that really allow them to incorporate monitoring into other assessment activities. So, for example, a past 2035 assessment, or an energy assessment, or a survey for retrofit recommendations. Most of what we do is about providing a tool set that helps professionals collect data, in particular temperature, humidity, CO2 data, also some energy data, from homes, maybe for a month or even up to a year, both before and after retrofit measures are delivered. These are meant to be easy to work with, but also deliver really robust data so that we can actually get into some reliable measurements of things like the heat loss, maybe the ventilation rates in the home, the risk of condensation. So we pay attention to things like providing sufficient sensors for each lived-in room to be measured, to using phone networks so that we have a robust coverage of homes across the country. And these things make it more straightforward to get the actual information that you might need. And we also, view monitoring in this sort of context as really a natural complement, if you like, to retrofit advice and even to technical modelling. which I imagine that some of the members at CIAT will be asked to get into technical modelling fairly frequently when making retrofit proposals. So whether you're trying to forecast the performance of design in terms of energy and comfort, measurement, we think, really strengthens that exercise. It has complementary aspects to modelling. Modelling has great strengths in that it allows for rapid forecasts of what will happen post-works, allows for rapid option evaluation. It's obviously non-intrusive for residents. And we find actually that it typically performs really well with immediately after works are delivered with effectively a new design. But of course, it is only as good as the data that goes into it and the survey that goes into it, and it can be fairly labour intensive. So it's not, in effect, an actual audited record of the real performance on the ground. This is obviously what monitoring is. It is an actual measurement of as-built performance. But along with the a measured performance, a model performance, what we can do is actually highlight deviations from the intended performance post retrofit. On the other hand, monitoring can take some time to produce a solid result. We normally look at a minimum of 3-week evaluation period. And of course, it can't be used to evaluate different options. So the two tools have very different strengths and I think combine together very nicely. I noticed actually that PHPP also is beginning to take into account this. I don't know if any of you guys use PHPP much, but it now has an input file where you can use data on energy consumption or indeed room temperature to compare to your design calculations. So let's explore a little bit of how this gets actually used in retrofit and in the projects that we've been involved in. Much of the work that we're doing right now is in larger scale retrofit projects, the sort of thing where housing providers are maybe looking at funding to deliver tens or even hundreds of retrofit projects. These typically use a lot of data throughout the process, especially in the early stages, EPC data for stock selection and for costing up funding proposals. Generally, where we get involved is much more at the next stage when funding has been secured and people are trying to get into the details of what measures might be used and what the outcomes for each individual homes might be based on those measures. So we would go in, we would do some monitoring pre-works, and then post-works, we have an opportunity to actually confirm that improvement. And where the measurements don't seem to match what the forecast might be, perhaps to have a look at ways in which we might fix the lower performance homes. And we're beginning to see that same principle now sort of trickling down and being applied to slightly smaller projects, even some of the self-funded retrofit projects. So in the past 2035 projects we're working with, we're typically seeing an interest in using better data to benchmark fabric performance, to benchmark an owner-occupied home, again, to maybe provide some anchors for any technical modelling to allow some option evaluation with real measurement, and maybe highlight risks around issues that the home might not be immediately obvious from survey data. And once we've collected some of these benchmarks, it then becomes much more effective to measure the improvements in the fabric post-works, give some assurance on delivery for clients, and if there are issues or there's a gap between what the performance intent was and the results, maybe give some guidance on possible causes for issues or whether those issues are most likely to be coming up. In terms of, I talked a little bit earlier about process and about how monitoring is best delivered using a reasonably consistent process. Well, whether it's large or small, most of this stuff follows the same basic process. It's really helpful for data privacy, if nothing else, to have a think early about what the point of the monitoring is. This is, as I say, certainly helpful for confirming the consent of anybody who's going to be monitored. And we'll touch a little bit about how we handle data consents and data privacy. But the important thing, the key thing is to make sure that people are aware of what's going on and why it's going on. Then we have a reasonably straightforward process where people on site install the sensors. Normally that would be delivered through, as I say, a professional who's already visiting the site, a surveyor, an energy assessor, maybe a designer, maybe a contractor. And if we're doing a heat loss calculation, then we'd also be collecting energy data alongside that. There are quite a few ways we can do that, so I'm not going to get into that right now. But suffice it to say, the options sort of include smart meter data, meter reads, possibly additional sensors. We'll allow the data collection period to be steered really by what the monitoring goals are. The minimum for good benchmarking data is 3 weeks. We're working on getting that shorter, but that's where we're at the moment. But it's not uncommon for us to do post-works monitoring where we're looking at seasonal impacts. So we might do a full 12 months worth of monitoring as well. And then after that, the system is designed to be removable. If you want to get your data for energy and you're doing a meter read, you need to remember a meter read at that point. And you can remove the system and deploy it into a different home for a fresh set of testing. The results typically for us get delivered either in a sort of one-off report. On occasion, we find that people want to look at the data as it's collected live. So they get wrapped up often in advice from a design professional about recommendations of what to do next. So we're very much doing the numbers and the pictures, and people like yourselves will be doing the words and the advice. I think Magdalena was keen that I talk a little bit about how this information works for residents as well, and how we both control and share it with residents. On the control front, people are much more sensitive about data privacy, I think, than they used to be. And so we have to be clear that we're doing everything that we do under a GDPR framework. But as long as you're clear up front about what it is that you're doing and who you're proposing to share the information with, generally we find it's not too much of a challenge to either get a consent or to justify the collection of the data under, for example, a contract for delivering services. You might want to share the data or the information from this with the homeowner. That would be the most common thing. You may well want to share it with other designers or experts in your supply chain. You might want to share it with a contractor or even with a funder. The key thing is just to identify a little bit about who this is going to be shared with, and think a little bit about how that format might come out. We currently find that actually the sort of tenants that we're working with don't necessarily always want to see day by day live data. We can share that if necessary, but most of what they're interested in is a snapshot of where things look like they might be going wrong or where there might be some advice to be delivered to them. So they're more interested in seeing sort of the snapshots with advice wrapped around it. So a little bit more perhaps might be interesting about what it is that monitoring can tell you, and perhaps a little bit about what it can't. So it's absolutely true that most people, when they think of monitoring, think of just the very basic data, the graphs, maybe a waterfall type visualization. And what we get out of the work that we do is plenty of data of that nature, data from the temperature, the humidity from multiple points within the home, the CO2 levels in the homes are a good indication of what air quality is like, and the energy as well. And that's actually really helpful. You can eyeball all sorts of things from simple graphs or waterfall diagrams. You can see where people are using their heating. You can see which rooms may have the highest risk of damp, for example. But we often find it most useful, or just as useful, to deliver some sort of single metrics of fabric performance, particularly where you are trying to compare the performance of a number of different homes, or where you're trying to compare performance before and after works have been done. Getting some single figure metrics is, a very quick way of allowing you to understand just how much progress has been made. So we spend an enormous amount of our time boiling down vast oceans of data into single figure metrics like heat loss calculation, a condensation risk profile, an understanding of air changes in the space, so that we can make those comparisons. And also we find that those sort of metrics are really helpful in terms of giving an overall sort of 360-degree view of the state of the home in the round, which steers a little bit which way you might want to go with the particular measures you'd recommend for that home. So to get into this in a little tiny bit more detail, heat loss testing in our world is a single figure that gives you the heat transfer coefficient for the whole envelope of the house. In larger retrofit projects, it's often used to identify the stock that are really in most need of fabric interventions. It can also be very helpful for sizing heat pumps. And what the tests that we do provide is a couple of measures: the overall heat transfer coefficient, watts per Kelvin, which is the difference between internal and external temperature. So in essence, how much energy does it take to raise the inside temperature 1 degree over external temperature? And that scales according to the size of the home. So in order to make it useful for comparing different homes, what we would normally do is we would also provide a heat loss parameter, so that you get an understanding of the watts per Kelvin per meter squared of usable space in the house. Now, this is a kind of a measure of the rate of heat loss. What it doesn't actually do is add in the profile of heating demand, whether somebody prefers to have their home heated at 16 degrees or 21 degrees. It doesn't actually take into account the gains that occupancy might provide, all of which are necessary for the annualized kilowatt heating demand per meter squared. That's something that we think we need to look at, and I'd be really interested on people's thoughts on that when we get into the conversation. To do this test, of course, does require data on heating energy, so it's a test that we conduct in the heating season predominantly. Another thing we do, which is more related to sort of indoor air quality, is testing on ventilation, which is obviously an important piece balancing health and energy efficiency in a home. There's two things we can do with CO2 data. You can either look at absolute CO2 levels, which provides you an indication of just how well a home, how long a home spends in at-risk periods, or you can look at how quickly CO2 data decays, and that gives you a measurement of how quickly air is replaced in a space. So it's very sort of sits very nicely alongside an air tightness test or an infiltration test. But because it includes a behavioral element, we do this test while people still live in the home. They may be opening windows, they may be shutting trickle vents. It includes that behavioral element. So it's not the same as an air tightness test. What it is actually a reflection of the home's real heat loss in effect through ventilation when it's lived in. And finally, the other thing that we do very regularly is we use humidity data to identify moisture risks inside the home. This is within the envelope of the home, so it's not an interstitial moisture risk test. It's basically a test that looks at, on a room-by-room basis, in rooms where we have sensors, what's the risk model based on average RH in the test period and the duration and peak of RH events. So that allows us to identify rooms and timeframes that are most exposed to damp and condensation, damp and mold risks. Okay, so this next slide is really rather complex, and I won't go into it in an enormous amount of depth, but it is really useful. What it's saying is it's really useful to consider all three of these measurements when you're thinking about your recommendations. I mean, monitoring, it can't tell you what materials you should be specifying, but it can steer you quite strongly towards whether you might want to put more emphasis on low U value EWI or maybe MEV. I mean, essentially what this slide is looking at is, of the three major factors that contribute most to total energy use, the fabric, the behavior, and the weather in the building, what is it that we can measure out of these? We can measure heat loss, which is really very much a focus driven by fabric. We can measure things like ventilation rate, which is a combination of fabric and behavior. Infiltration rates are very much more determined by weather. CDM risk is complex and basically has inputs from all three of these areas. But you can see that, where you have a home, for example, that has a profile with a high heat loss and a high ventilation rate, you may want to focus on a different set of solutions to a home that has a very high condensation, damp, and mold risk and high ventilation. So there's a little bit of advantage to having these metrics, considering all of these metrics alongside each other. So finally, very quick counter over an earlier project that we've done out of hundreds of homes that we've done. This one, I think, was really quite informative in terms of how this comes out. We just finished up a 2-year project with the London Borough of Havering, where we've been testing more than 50 homes, which I think was about 25% of the homes that they had in retrofit. These are mostly interwar, post-war homes. They're reasonably similar, but they split them out into 7 archetypes, and we did the pre-works testing and indeed the post-works testing across 2 equivalent winter periods. Much of what was done was EWI. Havering were interested in using this information to kind of inform their design decisions, validate the performance, give confidence to residents and funders, all the stuff I've just been sort of talking about. We got the contractor to actually put the kit in while they were doing survey work and organising EPCs. They did very well with this, actually. They got really very good at it. We trained them up with a couple of visits, and then essentially they got to the point where they were happy. It was sort of less than a 30-minute install for most of homes they did. And the feedback we were able to give helped Bailey Garner, who were doing most of the design work around this, to fine-tune their recommendations. Mostly it was around CDM risk, as you might expect with a social housing landlord, but also, some of the post-works reporting we've been done has helped Havering understand where they might want to go in and provide a little bit more feedback to residents about maybe how they're controlling their heating and adapting to the fact that they've got much more thermally efficient homes now. But the thing that was quite interesting that I didn't really expect was we put quite a bit of work into comparing the SAP models that Bailey Garner were using with the testing work that we've done. And pre-works, the SAP models were generally overstating, particularly heat loss, quite significantly. And we think that might have been associated with some of the forced assumptions that SAP tends to infer when you don't have good enough information from a survey. But post-works, the models were coming out really quite close to what the heat loss that was forecast, the heat loss that was measured, was measured, which has given us some confidence that where you do see a measured heat loss that doesn't match the sort of forecast from a model, that may well be an issue with the actual quality of delivery, and you might want to invest in some more forensic investigations as to what could have gone wrong there. By and large, Havering are very pleased with this, not least because the tests show, reductions in 26% in heat loss and improvements in the ventilation of over 50%. without compromising any moisture management. So from the perspective of convincing the funders that the money's been well spent, they're very happy with this. So that's a very quick gallop through what is, as you can imagine, quite a detailed subject, but I hope it's given you all an opportunity to dabble your toes in the waters of data and how it might be used in retrofit. I'm very happy to answer questions or to get into debates about how you might use this. So I'm going to cut out the presentation now and go back and have a look at the chat and the Q&A.
Perfect. Thank you so much, Hermione. That's been really, really interesting and informative. We do have one question. So we'll start off with that because this is something that I was going to ask anyway. And it is to do with the placement of sensors and how can we gather accurate and quality data. I'll read out the question because there's a little bit more in it, so I don't miss anything out. It's a question from Mohammed. He's asking about the installation of CO2 monitoring sensors, and specifically, was the suitable number of sensors per room, the optimal location, height and distance from windows, and I suppose radiators, and if there is a specific British standard to follow. Also, if the same sensor is used to monitor humidity and temperature, what would be the impact of the location to effectively monitor all these indicators simultaneously?
Hello, Mohammed. Thank you very much for being brave and putting your hand up on the first one. This is bread and butter for me. Love this sort of question. So there's a collision between theory and reality when working in housing. It's one of the reasons why we don't use multifactorial or multi-metric sensors, is that you need to be measuring things like CO2 at a slightly different location within a room, typically, than you would measure temperature and humidity. So we issue guidelines which they try to balance being reasonably generic with reasonably specific, if that makes sense. All the obvious things: don't put temperature sensors anywhere that you might get direct sunlight. Don't put them next to radiators unless you really want to measure heating usage. Try not to put them on mobile fixtures because they will then wander out of the room that they're in. All of these things. But even I fall foul of this from time to time, and have recently, for example, discovered what I thought was a very interesting cycling behavior in one home, and it turned out I put the sensor a bit too close to the back of a fridge. So the fridge was cycling, and I could see a little bit of this. Now, for what we have to do about that is, for calculations that we do, we have to make them robust to features like that. So in the case of the heat transfer coefficient, that's one of the reasons why we have multiple sensors in the home. We have, typically for a small to medium home, we'll have 4 sensors: kitchen, bathroom, living room, main bedroom. And we'll pick up the data from all of those and use that to sort of correct for any obvious issues. The CO2 sensor we would normally put in the living room or the kitchen, so we need it in an occupied space. We can add additional ones in if you want to do more in-depth work, but by and large, the sort of minimum package that we would recommend is to have those 4 sensors and a CO2. Does that help?
It does. Thank you so much.
Yeah, no problem at all. Yeah.
I can see that Gary is still typing, so maybe
I'm frightened.
That's no, I'm sure I'll be fine. I wonder if you could maybe expand a little bit on what you talked about in terms of heat pump installation, because it was a very valid point. I think there's a certain fear at the moment over installation of heat pumps in homes that might not perform as we expect, and that some homes are not suitable for installation of a heat pump at all. So I suppose having this measured data while in use will ensure quality control. Can you tell us a little bit more about that aspect?
That's a project that we're getting very deeply involved in at the moment, with some DESNZ funding to try and produce a variant of this tool that can be used by heat pump installers. I mean, in truth, my heat pump sector friends tell me there's no such thing as a home that isn't suitable for a heat pump, provided you've got bottomless budget. Yeah. What we're actually talking about is making sure that heat pumps are not oversized in order to reduce the impact on homeowners, increase uptake, and also reduce the impact on the grid. Now, the work that has been done, there's been quite a bit of work done on what happens if you try and size heat pumps based on the standard heat loss calculations that the British Standard recommends, BN 12831, if anybody's interested in that sort of thing. The upshot of this is that, this is similar to the SAP model, you're going to find about 50%, 40 or 50% of homes oversize the heat pump quite dramatically because the heat loss calculation just isn't, it's really difficult to do really well without knowing exactly what the build up of the building is. And that doesn't matter when you're thinking about the population of EPCs, because for several thousand EPCs, the errors will correct either way. They may be oversized or undersized, but on average, you'll get the right result. But it certainly matters for individual homes. So what we're trying to do is deliver a tool that gives a much more custom estimate of what the heat loss is for the home, and therefore helps you size the heat pump to the minimum necessary to get an efficient result.
Perfect, thank you. I've got a question from Gary. He's asking about the case study that you mentioned and making reference to the SAP figures, and asking if they were RD SAP or. As far as
I know, that was full SAP, because it took some man hours to get them done. In fact, I think so I think they were very much doing that as thoroughly as they possibly could.
Perfect, Gary, you're more than welcome to come in and ask more questions or follow up from this as well. One more question that I had that I thought that we could discuss as well is monitoring of other things like PFAS and particulates, VOC levels. This is obviously not covered because this is something that's sort of additional, but essential to understanding health and well-being of the occupants. Could you tell us a little bit more about whether your product could also offer additional monitoring, or is it something that you would be planning for the future?
It's something we have done in the past, more in educational settings and in workplace settings. The challenge with it is a commercial one rather than a technical one, which is that to get a good quality particulate monitor or a good quality VOC monitor, and is actually adds, £400 or £500 to a typical monitoring package, and it becomes something that many homeowners and indeed many landlords, just don't necessarily see the benefit from. In an office or educational setting, it can be a little bit different rather, because it can be used as a selling point, so sort of BREEAM certification or WELL certification, things like that. It's a slightly different issue.
Perfect, thank you. We've got another really good question from Hamid. He's saying there is a lot of noise around the impact of MVHR on indoor air quality, and he's wondering if you have been involved in monitoring of very airtight house with MVHR.
I have, but I don't have the results for you yet. Maybe I should come back and do a part 2.
Yeah, absolutely. We can put you in touch with Mohammed as well, and you can discuss that further. But I think it's a really important question to ask as well, because as we're trying to understand how these very airtight houses perform, and when we rely on mechanical means of ventilation more and more, what impact will it have in a long term on occupants, and maintenance, and even understanding how the building is being used and how it performs. So another question that I had was in terms of your system being used for educating the user. Can the occupants actually see how their house operates and what's good and what's bad for them, and change their behaviours potentially?
Yeah, so they can. As I've sort of touched on, in a sort of classic retrofit scenario, we won't necessarily be in for anything more than a year. But we can absolutely share the data on their own dedicated web page, and they'll see that sort of the graphs and what have you. What we haven't got at the moment are many ways of interpreting the graph automatically for people, because we have two tribes effectively. We have people who I suspect, I'm probably talking to the majority of people here, are really into data, really like data, can read data, can make sense of data. That's probably not the mass market for homeowners, and it's certainly not the mass market for housing tenants. So to go down that route, we probably need to be providing a little bit more of, this is what you need to do. We are getting involved in providing a phone app for some tenants to give a little bit more insight into what to do about condensation and risk management, that sort of thing. So there will be potentially an opportunity to do that using a phone app going forward. But right now, the key way we do this is either with that web delivery of the data through a web portal, or we rely on the professionals who are providing this to go back with a report to say that says, it looks like it was this, and maybe you should consider, I don't know, turning the heating down. I just may share a little anecdote with you, because this is now, I've seen this in quite a few homes that we have monitored. The classic one of you measure a home's heat loss before and after, you see a significant improvement in or rather you don't see a significant improvement in the heat loss in the home. You think, what on earth is going on here? Because you know perfectly well that next door has it's had exactly the same measure and has seen a real improvement. And then you find out that what's actually happened is that the temperatures in the home are sitting at 26, 28 degrees. The heat loss, and the tenants are not turning the heating down, they're just opening the windows. So the ventilation rates go right up, the heat loss goes right up. We don't record an improvement in the heat loss, but what's actually happened is the fabric has improved, but we're just losing it all through ventilation. So this again is why you need to see sort of a range of different metrics of performance. And obviously you then go back and give a little bit of feedback to the residents about how you might manage your home a little bit better to reduce your bills and to accomplish what you're interested in terms of comfort.
Perfect, thank you. Another question that I had was around data management, but not under the GDPR, but obviously where that data that you collect is stored and how is it being passed on to others? Do they log into your system? Is it like a cloud-based system and it just sits there all the time? Is there any fees associated with management of that data? And obviously it's short time of monitoring as well. So I suppose for some clients, it would be sufficient for you to then pass on that data to them and they can do whatever they want with it. But to ensure that this data is then used correctly and it can be reused or it can inform decisions, how is that being controlled?
Right, yeah, good point. So the commercial setup really is that the data comes back to a web-based platform. And this is essentially, we have an annual service fee to host that data and to run the calculations on it. It's available, you can allow clients, householders to access it. You can invite different people to different projects within that setup. And we essentially allow that you can also share privately parts of that on a sort of on a separate web page that's customized for that particular customer. So there's lots of different ways of accessing the data, but whoever is owning the system and running the responsibility for the testing would be expecting to pay an annual service to keep that data, and indeed to cover the costs for us of taking the data from the sensors and delivering it back to the web service, because that's all done using a SIM card, and unfortunately they don't come for free.
Perfect, thank you. And because we've started talking about cost, perhaps you could just tell us a little bit more about the cost of the system as well, and we'll close at that.
Yeah, sure. Excellent. I'm going to make a pitch. Right. So the standard system that we run, which I've been talking about, is designed to cover a small to medium house. So like I say, 4 temperature and humidity sensors, a CO2 sensor, the gateway to take the data back to the web service, and it bundles in a year's worth of service. So that is £700. We would expect that to be used for testing in multiple homes within the first year. So, the goal for us is to try and keep the test costs per home down. So you're rotating it around each home and setting up a fresh set of tests every time is probably the most economical way of using it. But there are some, clients who are quite happy to spend, £700 on a year's worth of monitoring. I mentioned a service charge earlier. So after the first year, then to review the service charge, at the moment, we're looking at £175 for that test kit. And it doesn't constrain the number of tests you can do. You can do as many tests as you like every year using that test kit.
Perfect, thank you. If nobody else has any more questions, then I think we'll close at that. Thank you very much, Hermione. It has been a pleasure and great to hear about things developing as we go, and hearing about your projects and background experience as well.